I'm Becky Lunn, and I'm a professor in the Department of Civil and Environmental Engineering at Strathclyde. I would say that there are probably three main challenges that I can think of particularly. So clearly a huge challenge is cleaning up our legacy sites, so decommissioning our existing nuclear sites, packaging our wastes, put them all into safe, stable forms, and then ultimately disposing of them in a new geological disposal facility. So we need to remove that historic legacy for the industry to move forwards, I think, and restoring land back to common use that's currently in the nuclear sector. Then we have a transition that has to happen to net zero. So by 2050, we need to be meeting net zero carbon. Nuclear has a very big role to play in that. And that transition period will be difficult. So there's a lot of things that need to be built. We need to transform our whole energy sector, and nuclear has a large part to play in that. But there'll be a period, I think, where we will struggle to be generating enough low carbon energy, and we want to continue our existing assets out as long as we possibly can safely before we decommission them and take our old fleet offline. So there's also the plant life extension of the existing fleet. And then for me, probably the biggest challenge is to make sure that the new build nuclear that is vital for our future, all these new power stations, possibly small modular reactors as well, that may end up being the future of energy in low carbon, that they don't leave the same legacy that our previous fleet did. So we need to learn from our previous legacy fleet and make sure that this time we design something from cradle to grave, so that we are designing with recycling, reuse and decommissioning in mind from the outset, and we don't end up with these very difficult and challenging facilities at the end of it. Strathclyde does something quite unusual in nuclear. So rather than focusing on nuclear materials and nuclear fuel, which is what most of the UK sector works on, at Strathclyde we do a lot of work around extending the life of existing assets, having sort of smart digital infrastructure, and thinking as well about the civil infrastructure in a plant, which is obviously what I do from civil engineering, but actually that's quite unusual. Most people are really geeky and interested in the actual power production and the reactor side, but the vast majority of infrastructure on a nuclear plant is just huge amounts of civil infrastructure, lots of concrete, lots of steel, and we need to think about how we design that into the future so that we minimise any radioactive waste that is produced. We know exactly how we're going to handle that waste and exactly how we're going to decommission those sites. It's planned in right from the outset. And I think that we have the skill set at Strathclyde, working with others around nuclear materials and robotics and other areas, but we have quite a unique skill set at Strathclyde to deal with that challenge. So we need to work with others. Nuclear is an immensely complicated problem, particularly if you look at legacy. We have a huge range, I think the largest collection of different types of nuclear waste materials and exotic fuels in the world. We tried lots of different things in R&D both for the defence sector and for the civil nuclear sector over decades from sort of post-war, and now we have to deal with those materials, and those materials are stored in degraded in civil assets, so buildings, stores, vaults that are gradually deteriorating. They were old, they are not built to last 80, 100 years as structures, and they make dealing with these very hazardous materials much more dangerous because the structures themselves are now fragile. So to solve these problems, we need to work across the UK with other departments that are experts in this. So, for example, I work with Sheffield University, who look at vitrification of waste, so turning very hazardous high-level wastes into glass, so making them stable. So some of the work that we have been doing at Strathclyde, we're looking at grouting those wastes to make them safe when you actually grab them and pick them up and remove them so that you don't get airborne particles. But then we're working with Sheffield to think, well, once we've grouted it and grabbed it and we've put it in something that stops the airborne particles being emitted so that you can't breathe them in, or then how do we turn that into a glass waste form that is safe and will be stable for thousands of years?